Hello. Let's take a minute today and discuss some of the challenges of having a larger aquarium with large fish. You require a large filtration system, about 800 watts of lighting for this aquarium. It's about 4 feet deep. Some of these items for the filtration and the lighting especially generate a tremendous amount of heat, and especially in the summertime, without a chiller to cool this water would probably in excess of 95 degrees. So I've come up with a system. Just going to feed these guys a second. You can see they take pretty big food, pretty big fish, and they create a lot of waste. What I want to discuss particularly today is a way of dealing with the heat that an aquarium like this could generate. What is usually done with an aquarium of this size is you would have a chiller. The chiller is extremely loud. It's a lot of money to operate as far as energy consumption is concerned. And what it basically does is it removes heat from the aquarium while displacing the heat back into the living space. So although you are getting the heat out of this aquarium, you're only putting it into your own space, making your own system work that much harder. Right now, this water is above 80 degrees, therefore the chiller just turned on. But as you can hear, the chiller is loud. It's definitely an annoying item to listen to, and I would say the biggest shortcoming with it is that the heat that is removed from this aquarium is only displaced back into the room. This top area here is called an evaporator, and that evaporator coil will take the heat from the water and remove it through the chiller and then displace the heat back into the same exact room with a condenser. The system I came up with my son was to use the power of the earth, geothermal cooling, to cool this water, and not using the chiller. As you can hear, the chiller is considerably loud, and it does use a tremendous amount of electricity. What we did is we did a test hole in our own basement about 6 feet down, and we found water, and we found that water to be about 65 degrees Fahrenheit, considerably cooler than the aquarium water. So we came up with a system to displace this heat rather than in the room with the chiller, but to displace this heat into the ground, into that water. And I'm going to take a minute and show you how we did it. Okay, so take a minute. Some of the heat sources are, I have an ETSS 800 protein skimmer. That has a Blue Line 55 motor on it. I also have the main sump pump. It is one of the more efficient motors as far as energy is concerned. It really works well, but it does put heat into the water as well. I have here a UV sterilizer light. That also puts heat into the water. As I stated, I have over 800 watts of lighting for the depth of this tank, which is about 4 feet. So you need a decent amount of wattage for a tank that deep, otherwise it's just going to look dim and poorly lit. Plus, this tank is also built in. Okay, it's all built into the wall. So you really don't have too many options as far as cooling it with just air passing through it. It's against a exterior wall there, it's against a closet here. So there's not too much ventilation. So it really is a challenge to cool a tank like this. It's quite beautiful, but it's definitely challenging. Here I have a live sand bed filter. back here, I have a tower that sits behind the protein skimmer, and that has all the bio balls. That worked out quite nicely. You can see it back there. A little difficult, but it sits right behind the protein skimmer. And this is the item I kind of want to talk about a little bit. Right now, if we look at the temperature of these polypropylene lines, they're approximately 79 degrees. These lines go directly to a coil, which you can see right behind the intake. If you look right there, that's 5/8 tubing in a coil form that circulates cool water, and that is now going to be taking over to replace my drop-in chiller. That cool water is displacing heat from the sump to about 6 or 7 feet below my basement floor. The coil, when it was straight in stainless steel, was about 10 feet long. It has to be all 3/16 stainless steel. Any iron, brass, copper would definitely do harm to the fish, or if not outright kill them. So it must be stainless steel, anything that's going to go into the sump. Very important. This is my Medusa controller. That controls the chiller now. I am going to be having the same controller control a circulator pump, which is going to circulate that cool water. This is a closed system. The water that it circulates is never in contact with the actual aquarium. It only goes through a coil. And I'm going to show you some video of how that's done in the basement, and then I'm going to videotape a few pictures to give you some idea on how to accomplish this. Okay, under our house is all sand, so some of the challenges that we had, this was actually, if you could see this, this was a riverbed that we hit all river stone there. But we used this PEX tubing to actually hold the sand back. If we had dug it without installing the PEX as we went down, this sand would have all collapsed on itself. And at about, probably, this area is about 5.5 feet is where we hit water. This PEX still continues under that water for about another 18 inches. And again, using the PEX the entire time to keep the integrity, because as this sand got wetter and wetter, as we excavated deeper and deeper, the integrity of the walls were just falling continuously. We came up with the idea of slowly wrapping the PEX around the hole. This hole is probably about 2 feet wide, and like I said, about over 6 feet deep. Up here, the integrity wasn't a problem. To get to this riverbed, we went down about 3 feet. So this is probably about the 3-foot mark. And then we go considerably deeper, because this is what we wanted to get to, this cool water which is under the house. This cool water is a great way of completing this heat exchanger, to get that heat out of the aquarium, not putting into our own living space where we're only going to have to run the air conditioner to cool the house. We are getting that heat through these tubes into this cooler water, about probably 65 degrees. I'm sure it'll get warmer as the months go on into the summer, but I'm confident it will probably never get above 70 degrees. So I believe the system will always work. Okay, right here, this is the coil. Like I said, that coil is about 10 feet long. It's all made out of stainless steel, which again has to be stainless steel if it's going to come in contact with the water. And this is the other half of my heat exchanger. This is what sits in the sump, and this is what will extract that heat from the sump into the ground. So this component has to only be stainless if it's going to sit anywhere into the aquarium, or titanium. But brass, steel, or copper